Hello, Coach Holmes here, and today we're going to be talking about rotations. Now, this is a different type of transformations as opposed to reflection. Rotation is a transformation where a figure is turned at a point. Okay? Now, if I have a certain point and I rotate it, that's called a rotation. There's a certain point that allows me to rotate. And that point is called the center of rotation. It's the point where the figure is rotating at. Okay? So for our case, when we deal with rotation, our center of rotation is always going to be at 0, 0. Okay? It's not going to be at 1, 1. It's not going to be at 2, -5. The center of rotation is always going to be at 0, 0. Now, however, we are dealing with counterclockwise. We always deal with counterclockwise when it comes to rotation, unless told otherwise. But 9 times out of 10, we're going to be dealing with counterclockwise. And really, counterclockwise, opposite direction of a clock. Okay? Counterclockwise is the opposite direction of a clock. So if the clock goes this way, counterclockwise is the opposite way. Okay? So this would be counterclockwise, where it's going against the clock. Okay? Now, there are some rotation rules. Okay? But luckily, they always apply when we're rotating at 0, 0, which is going to be the case. So for example, the rotation rule for 90 degrees is that when starting from x, y, we not only switch the y and the x, but we change the sign. So our new x is going to become negative. Okay? Now, when it comes to 180 degrees rotation, we initially make both negative. Both x and y will become negative instead. So instead of saying, so when we go from x, y, we go to negative x, negative y. And then from 270 degrees, we're actually going from y, negative x. So not only am I switching the x and the y, but I'm changing my signs as well. Okay? Now, probably be easier for us to actually write down the points and then we plot them accordingly. So, my center of rotation for all three of these is at the center, the origin. Okay? So that's always going to be my rotation. Now, so for point A, that's going to be 1, 2, 3, 1, 2, 3, 4, 5. So my point is at 3, 5. B is at 2, 3. C is at 2, no, not 2, I'm sorry. Matter of fact, B is not even 2, 3. It's 3, 2. My apologies. C is going to be 1, 2, 3, 4, 5, 6, 2. So we have 3, 2. For point B, point C is at 6, 2. Now, what I want to do for point A, for my image A, actually, because remember, pre-image is before the transformation, image is after the transformation. So, basically I switch the values. But notice that I changed my sign right here. So my new point is going to be a negative 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. So that's point A. Point B, remember, I switch my X and Y, change the sign for X. 1, 2, 1, 2, 3. Switch my values, change the sign for X. 3, 4, 5, 6. Okay, so that will be my rotation for 90 degrees. Now, the next thing I want to do, I want to be able to do a rotation for 180 degrees. I want to do a 180 degree rotation. So, labeling my points. I know point A is going to be 1, 2, 3, 4, 5, 6, 7, 8, 2, or negative 8, comma 2. Point B is negative 3, 2. Point C is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Negative 6, comma 5. Now remember, I'm not switching my X and Y for 180, I'm just changing the sign. So instead of saying negative 8, 2, I'm going to say positive 8, negative 2. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. So that's my new point. Point B, remember, I'm changing my sign for both, so that means it's 3, negative 2. And then again, changing the sign for both. So 6, comma, negative 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So you just got to remember that with 180 degrees, I'm just changing the sign for both X and Y. The next thing I want to do is figure out the rotation for this figure at 270. So I still want to label my points. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So negative 3, negative 8 is A. B is negative 3, negative 3. And then point C, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay? Now, so for point A, remember, I'm switching the negative 8 and the negative 3, but my new Y value is going to change. So instead of saying negative 3, I want to say positive 3. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So then my B prime, which that's how we call it, with B with the apostrophe, it's called a B prime. Just how many different transformations we have. There's not much of a switch here, but my Y value becomes positive. So I get negative 3, 1, 2, 3, 1, 2, 3. Not much of a switch here, but my new Y becomes positive. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay? So that's how a rotation of 270 degree will look like. Okay? Now, you just gotta remember, just like 90, I switched the X and Y, but the biggest difference is that my new Y value will become negative, or initially change sign. Now, we did talk about line of symmetry where we actually fold something in half. But this time, we're actually going to be talking about rotational symmetry. Rotational symmetry. So what is rotational symmetry? A figure that can be rotated about a point and map itself by rotating. Okay? So rotational symmetry is a figure that can be rotated about a certain point, which will pretty much be the center of the figure, and map itself by rotating. Now, if I were to rotate this figure right here, I would say about 6 times. At least 6 different times it will rotate itself evenly. Now, so there's 6 lines of symmetry, or 6 lines of rotational symmetry. Now, we also want to know the degree of those rotations. Like by what degree are they rotating? Well, it's pretty simple. One full rotation is 360 degrees. Now, how do we determine the actual rotation? Divided by the number of lines of rotational symmetry. Since we have 6 different rotations, I divide by 6, that gives me 60 degrees. Okay? Now, so right here, for example, I'm going to have 3 different lines of symmetry right here. So looking at it, if I have 3 lines of rotational symmetry, and I want to figure out the actual degree of each rotation, again, divide 360 by 3, make it 120 degrees. Now, if I rotate this figure, it's not going to map itself until it actually gets to the original position. So there really is no rotational symmetry for this right triangle. So there are figures that have rotational symmetry, but there are also figures that don't have a rotational symmetry. But what the key is that if you were to imagine rotating it, it would actually map itself. That's what you want to look for. Are you able to map itself on the rotation? But the biggest thing I want y'all to keep in mind is the rotational rules, okay? Because these always work. So for a 90-degree rotation, switch the X and Y, change the new X value. Change the sign of the new X. 480, you change the sign for both X and Y, but you don't switch them. 270-degree rotation, you switch both X and Y, but you change the sign of the new Y value. You do all that and you'll be able to figure out the rotation of 90, 180, and 270-degree rotation. Thank you and have a good day.